Have you ever wondered if your infrastructure experienced an acceleration in its deformation after a major storm? And if so, can you measure the exact magnitude of that change? When managing critical assets, answering these questions are essential. Which elements of the infrastructure are responding to temperature changes? Is the observed movement linked to intense rainfall, groundwater variations, or other external drivers? And how do we distinguish between expected, stable behavior and an early sign of structural risk? To answer these questions in a systematic and objective way, we turn to InSAR satellite technology. Interferometric synthetic aperture radar allows us to measure millimeter-scale displacements continuously over large areas, providing a high-resolution view of how our assets and surroundings behave, without the need for ground sensors. However, InSAR data alone is only half the story. To truly safeguard infrastructure, we must move beyond description and into interpretation. By combining InSAR results with advanced time series modeling, we can isolate the influence of external variables such as hydraulic pressure, soil moisture, and thermal loads. This makes it possible to separate normal seasonal responses from unexpected structural anomalies. This is where MoMo, motion modeling, comes in. MoMo uses the multiple hypothesis testing method to compare physically plausible behaviors and identify the simplest, most accurate model for every data point, delivering clear results in terms of deformation velocities, breakpoint dates, and sensitivity to external factors such as temperature or precipitation. MoMo transforms complex satellite data into actionable intelligence, supporting informed decisions on the resilience and safety of critical assets. The MoMo platform is available in both English and Spanish, and you can switch languages at any time using this menu. Support and docs are also found here. The interface is organized around a central map that you can customize and 3 main functional panels. On the right-hand side, you'll find your main command panel organized into 3 tabs. In Scenarios, you can access all your data organized by projects. Let's add some data. In Upload, you can import new InSAR datasets, currently supporting EGMS via download links, as well as climatic variables. The Model Fitting tab allows you to configure and save your models. You can choose dataset properties and load the points directly onto the map. The panel on the left controls styles and legends. Here, you can select which point property is displayed, adjust color palettes, point size, transparency, and legend ranges to highlight the most critical areas. The bottom panel is activated when you click on any point on the map. A ring highlights the selection on the map, and the corresponding deformation time series is displayed instantly. You can select multiple points to compare different structural elements, such as the dam crest and the concrete spillway, revealing distinct deformation behaviors. In the second tab of the bottom panel, you can manage the plot display. Show or hide specific series to focus your analysis. When a model is fitted, you can visualize its individual components, the linear trend with breakpoints, the thermal component, or the hydraulic response. This concludes our quick tour of the MoMo interface. We've shown how to access the platform through Destin-E, manage and upload InSAR and climatic data, and interpret deformation using the MHT-based modeling approach. As a next step, we recommend continuing with MoMo documentation and advanced tutorials, where we explore modeling workflows and result interpretation in greater depth to support operational decision-making. Start exploring MoMo today in free mode and discover how advanced modeling can turn your infrastructure deformation data into clear, actionable insights. Thank you for watching, and we look forward to your contributions to the Destination Earth community.